Hello there, Larry Trussell here. Welcome to our session on Synergy Electric. We're going to talk about using AMI data to run load flows over a period of time. I think everything is working here. We are recording and sharing a screen. Microphone, I think, is working. And if you have questions or things you'd like to look at, then please chat away. I'll try to keep an eye on that. All right, get rid of this and start up Synergy Electric. So I've probably met a lot of you and we've talked over the years, but by the way, the long time ago, back in the mid 90s, I think our office was kind of right over in here. It was a 6-story building kind of tucked away here in Seattle back with Scott and Scott. And that business has been around since I think since like the 70s, consulting with Walter Scott, I think in St. Louis. And then they were bought by R.W. Beck and then established as kind of an independent company eventually. Scott and Scott sitting down here, and that's where I started. And so it was really great to be able to walk around the city and check things out over those years. And then we were acquired by Stoner Associates and moved to central Pennsylvania, which is a beautiful place. You know, a lot of rural areas, very green, and especially this time of year, it's pretty spectacular outside. All right, a little history. So before we jump into the AMI and the 8760, I'm show you some of the things that we have coming out in the next version of Synergy Electric, which is 618. And if I've talked to some of you in web meetings recently, our goal was to have it out this week. Testing's not going so well. We're finding some issues. And so it's probably going to just roll into a normal monthly update. So we'll probably end up posting it. Well, I don't know. It's maybe next week. Maybe next week if things go well. If things go better with testing. And then we'll get started on 619. So some of the things that are coming up. One is a new application. It sits over here on the reliability. The Teams bar is up here, and it's kind of odd. It interferes a lot of times with, okay. So on the reliability tab, this is not a licensed application. It's just over here with a lot of these other applications. And I think in the last few weeks, we did talk about stuff that was licensed and not licensed, but even an application like reliability, everybody can run it, get feeder-based metrics. But if you have the license for reliability, then you can get into the details, root causes, a lot of that stuff, a lot more of the deep analytics in reliability. This is an application for placing reclosers in the model. And if we run it, it's going to place one recloser on each feeder. So it's one recloser per feeder. It is a suggested location. I try to avoid the word optimized, or because there's so many things to consider. So in this case, we think we have a good location identified, and you can go and check it out. So the suggested section is listed here. And then what we're showing is the SAIDI value before and after that recloser is placed. And so we can see here the improvement. And so some of these feeders like New Cove, it's pretty dramatic, 60% improvement in SAIDI by putting a recloser at this location. And we can go and check that location out with a right click and a zoom. So it's this section right here. Kind of makes sense. This thing feeds down here. It's a fairly small feeder. Feeds down here and then off into a bunch of stuff down here. So that's what the report looks like. There's not a lot. I'm going to talk about what these numbers are all about. But what we're looking for is, all right, what sort of improvement are we seeing? So you can scan down here among all your feeders and see if it makes sense to put in a recloser. And if you have suggestions, and I've showed this to some clients this week and have already heard some very good suggestions, please send them to us. You can chat for sure, but on the support tab, there's this give us feedback button with ideas, or email technical support. Once the recloser placement has been run, you can go to the results tab, and there's a set of a result set here, and click on the recommended, and it will show the sections in red where Synergy is recommending placement. So you can see these graphically. And once we get going with standard training again, some of the first sessions we'll talk about how you can go in here and adjust the line width to make the red section stand out. Maybe something on our to-do list is to recognize result sets that are binary in nature, because these result sets it's either a 1 or a 0. And it would be nice to have a button here to get rid of this gradient and just have a red or a not red type of thing. So we'll get to that eventually, but for now you can certainly see the sections. You can show them down here in this list, and so they kind of stand out. I've ran this on client models, and it seemed to be pretty intuitive. I think these locations seem to make sense. So that's how you can see it on the map. Now there's a recloser placement factor that we're using. So this is really the same sort of information. It's just showing the calculated values for every section. And what we're recommending are the sections that have the largest calculated value. So the calculated value, let's look at that. That's on the support ribbon. Technical reference. This will be in the updated technical reference. And we have in the overview, we have this thing called the Encyclopedia Synergy Electric. And it's a spot where we can start to accumulate one-page discussions on things. So we go into here, and there's this AMI 8760. We'll talk about this in a bit. And then further down, recloser, these are alphabetized. And there's a recloser placement here. Make this bigger, and I'll explain what it is that we're doing with this application. So in this diagram down here, we have this test location or trial location for a recloser, R sub T. So this is where we're going to evaluate a recloser location. So what's the benefit of this recloser? Well, if we have a recloser here, then normally if there's some sort of event happening down here that's not being handled by one of these downstream reclosers, then this upstream recloser is going to operate. And so all these customers down here are going to be out of service. Well, if we put a recloser in here, a trial recloser, then what we're doing is we're saving all of these customers from an event that happens down here. So the saved customers would be all of these customers less the customers in this little loop right here. And so that's what we're talking about up here, this customer saved value. So it's the customers upstream from this trial location. And then what are we saving them from? Well, we're saving them from events that would happen downstream here. And so we're calling that the exposure. And that's going to be all the lines down here that are upstream from these downstream reclosers. And there's two ways you can look at these values. You can look at it as miles of line, or you can look at it as failure rates, the cumulative failure rates on the model. So then what we're doing is we're taking the customer saved and we're multiplying it by the downstream exposure. So the product of these two give us a placement factor. And this concept was introduced to us by a client years ago. And we've had factors in SynE for a while. I think it is down in recloser or in reliability analysis. It would generate these factors and you could color the map by them. We've improved the approach here, and we've made it more mainstream by putting an application around it, and we're ready to put in settings. So the reason we did this was we're hearing from a lot of clients all of a sudden about recloser placement. And so that's an indicator to us that this is something that we really need to kind of start developing, or in this case, finishing. We started this application a long time ago. We need to finish it, get it out there so that we can get your ideas incorporated into the application. So the settings here for the application are pretty simple right now. You can either calculate exposure based on miles of line or by failure rate. And that failure rate is going to come from folks who have reliability established in their models. And that's going to be down here in the warehouse, these exposure zones, where you have categories of outages. So squirrel-related outages, as an example, if I had a three-phase line, then I'm going to have this many failures per year per mile on that line. So if it's a 5-mile line, I'll take 5 miles times this number, and I'm going to add that to all the other line sections downstream from the trial location for the recloser and come up with a total failure rate per mile. I'm sorry, per year. It wouldn't be per mile anymore because we know the miles. It would be failures per year. And then we can use that in those calculations. I think that is a much better approach than just using flat miles. So if you do have failure data, use that, because these numbers have come from the actual events that occurred on your system, from your OMS, the events that have occurred in the last 6 months or several years, whatever you've got, will determine these numbers, and then you can use these as a better indicator of exposure. Okay, so that's reliability. We've had some really good ideas for enhancements already, and if you've got some more, then please let us know. I'm going to move on to the next item for 618, and that's some improvements that we've made around time of day selection. And that is, I double click on the status bar down here, but you can also get to this on the model ribbon time and weather button right here. So these updates are definitely due to be made. A lot of folks are running time of day modeling, and naturally you come in here and say, all right, I could specify a time, which is I typically run this way, but a lot of folks will say, run at my peak, my system peak, which would be the peak on all the feeders that I have selected here. So some changes we've made are to incorporate estimated generation into these peak values. So before, if you have Synergy now and you're looking at this dialog, you're saying, well, geez, it used to say loads here instead of demand. What we were doing is finding the maximum load point, which could be very different from the maximum demand point. So this is going to take the total demand on all the, in this case, all the substations, and find the peak value. It is an estimate, so it doesn't make sense for us to run a full load flow for all 576 hours. So we're quickly running through, doing some arithmetic, and coming up with an approximation to determine the peak. And in our testing, it seems like it's working out really well to find the correct peak. So if I go in and I do this, I'm going to say, all right, let's do the peak demand, and I'm going to run a load flow. Then we can see down here on the status bar, that's a weekday in December at 5 o'clock is our peak. And then we can come in here and say, let's run the minimum demand, and it's KW. This is a significant change also. We were looking at KVA. And so with KVA, right, it's never going to be negative. KVA is always going to be 0 or positive because it's a magnitude. And now we're looking at KW. So if you do have reverse flow, then you could end up going lower and lower. There's a, you can go quite low when we're looking at KW. So for example, if before you had a lot of generation on a feeder, and that generation increased and increased, so at some particular time point you would get closer and closer to 0. When you had reverse flow, the KVA value would then turn around and start to increase because it's a magnitude. So you would have increasing KVA even though the flow was reversed. Now we are looking at KW values. So as that generation increases, you have reverse power flow. The demand is going to continue to go down and be a smaller and smaller number, a more negative number. So that's significant there. So if I go to minimum KW demand, and now we run a load flow on the status bar, I can see we're in June at 12 o'clock in the afternoon. And that's our minimum demand. And so before, when I ran this, it was probably some like 2 a.m. at some particular time. So let me go ahead and run hopefully this doesn't take too long here. Yeah, it's not too bad. We keep adding features to the 576. It used to be lightning fast. Now it can be a little time consuming, but so 576, that's the entire year. And if we look at this chart here and the megawatt demands, then this is where we can see then that the June weekday, so in June, we are looking at a weekday here. And if you haven't seen this before, this is probably a lot. We covered this in the standard training about weekday weekends versus peak day min days, time range, all that kind of stuff. So if you were part of that, then hopefully this is making sense. But here is the June curve, this greenish one down here. And our analysis was saying 12 o'clock, so it'd be right in here. So it may be off a little bit. 12 o'clock could be here, but it's certainly close to the minimum. And then the peak, I forgot what it was, but we could look up here. It was in December, I think. So December is this light blue curve, and so it was around, what was it, in the afternoon, like 5 or so. So it'd be 1700 hours. So we're pretty close right there. So that's what the time of day options are doing now, is doing a better job of finding the peak and the min time values. And I'm going to go back to specified time so I don't get confused. All right. We've done some work on scatter plots. One of the things we need to test, though, but when you run an analysis and look at the results tab down here, you can generate a scatter plot, for example. What the problem is that we're running into conflicts with other charts. So we've got to fix that problem before we get this out the door. I'm just going to close these. And but if you're on something, you can go in here and do a scatter plot. Hopefully this will come up. There we go. So these reclose replacement factors. probably wouldn't do that, but you can do voltage, voltage drop, impedance, things like that. The scatter plots are always miles from source, and then whatever you're plotting is on this axis. And then once this thing is up, you can go in and add more results in here and fiddle it around with the chart type and so on. But it's very convenient to just be able to right click on this and bring up scatter chart. This is a tool you probably haven't used much, but it's over here on the forge ribbon. There are these hammer, and the hammer is in there to fix data problems that you might have. And we use these a lot because we're getting models from all over the place, different clients at different levels of data processing, and there's missing stuff. And so you can see a lot of this is to create things that are missing. And so it'll just create a stub of a switch or a generator or something like that. But down in here, there is this obfuscate the model. And we put this in for consultants to use, because a lot of times they're under a non-disclosure and they can't send us a model because of that, but they're having a problem with like a fault analysis or something, and it's really tough to troubleshoot without having the model ourselves. So this obfuscate is in there. The obfuscate does rotate the model though, so it changes things geographically. So we added another option here to obfuscate with no rotation. So it's not going to change the coordinates of your model. It's just going to change the names. And it's pretty handy if you're troubleshooting something from your perspective. So you've got an area that you're looking at voltage problems or whatever. If you run the obfuscate tool, it's going to give the section names. It's going to make them much more clean. It'll start from the first section and just number them. So you can use that to come up with shorter section IDs and things like that while you're working on the problem that you're working on. And that can be pretty handy because I know a lot of you have really long section IDs. It's really tough to remember them or to keep a handle on them mentally. So the obfuscate can give you some more useful IDs. Now, if you do that, be sure not to save it back to your master model, because you wouldn't want to replace the master IDs and things. But it can be a handy tool. All right. There is we did some work on inverters over here. Sure, I'm not doing too much time here on inverters. We had a cycling problem where an inverter would trip due to high voltage. So example, this thing would trip and the generator was miles away from the feeder. So there was a significant impedance between the generator back to the source. So when the generator tripped, the voltage would drop down below the trip point and then it would activate again. And so it would just sit there and cycle off and on because of that. So clients told us about that. Thanks. And what we did was we put a reset in here. It's not labeled very well, is it? What this means is that it's going to trip on high voltage, and then it's going to stay tripped until the voltage drops below 126 minus 4, until it drops below 122. And yeah, so yeah, thanks, Leon. Let's talk about that in a minute. And so the reset button will the reset value will create basically a bandwidth. And we looked at capacitors and regulators and LTCs as the bandwidth concept. And if we had maybe done something like that to begin with, we'd be all right. But the problem is we already established this high voltage value. And so a bandwidth on this would really goof up this concept. And, so once we get something in place data-wise, it's really difficult to change it. So we wouldn't want to change this. So what we did was we put a reset on here, and it works in both directions. So if you got a battery and it were to trip on low voltage, then it's not going to reset until we're over 116. it seemed to work pretty well. And so you should see your analysis time go down dramatically, because it's not going to take 100 iterations like it was before if you had cycling going on. All right, so that's inverter tripping. And so the 1547, that is the interconnection standard, I believe. And so we are, how are we implementing? So we worked really hard trying to understand that standard, and this approach right here for volt-var functions, these coordinates, I believe, match up with that standard. So the approach, the fact that this is in percentage, this Q is a percentage of the active power capability of the device. I think that's the terminology they use in that standard. So this should be, if you've got points on your curve that are consistent with that standard, you should be able to put them straight into here. As far as things like ride through and all of that, that's work that we're gearing up to do, and that's going to come into play for things like contingency analysis on the capacity tab. A lot of these switching applications, we have to start to look at how these generators are going to operate in those conditions. Then we also have an application over here, a screener application that uses some screens that I think are consistent with that standard. So those are some of the things that we've looked at. And if there's things that we need to do that we overlooked, then please let us know. But I believe we're consistent with that standard in the ways that Synergy, we're doing load flows at fixed time points. We're not doing transient dynamic analysis, although we do have a time series analysis. So the ride through stuff is something that we're going to have to get into soon. So hopefully that helps, Leon. But again, if we're missing things, please send us a support email, feedback, something like that, and let us know, and we'll definitely want to jump on it. Last piece before I get into the AMI is on wandering laterals. And this is, sorry. This is a contrived little feeder that's got some wandering laterals in it. And we'll run across these a lot of times for switchgear, regulator banks, bypasses, things like that. And they look a lot like this. And you'll probably see these in your model. So we've got a three-phase line, breaks up into single-phase lines, and then forms back to a three-phase line. And here we've got two phases and one phase. So these are very common in those situations. They're also very common for underground residential distribution stuff. So you'll have these single-phase lines that'll go off into various pieces of the subdivision, serving homes along the way, and then they'll come back maybe two phases, and then another phase will break off. And so it's just a big nest of all these wandering, these single phase, forming multi-phase cables and then breaking apart again. Conceptually, they work the same way. They look a lot different. But what we've done with the wandering laterals is improve fault analysis a lot. And so it used to be the case when, and I'm going to talk here fast, when we were running fault analysis, what we do is we take the source impedance and we start pushing it out along these lines. So when we go along a three-phase line like this, we're just adding up the impedance of the line. And back in the Seattle days that I was showing you earlier, memory was a big deal. There was not a lot of memory to work with. It was very tight. And so when we were building the Synergy engine, we were really focused on just propagating positive and zero sequence impedances. And so we're able to do that, add that up all along here. Well, that doesn't work when it's okay when we break apart. We can move sequence impedances along here, but when we come back together, it doesn't work. So we need to know what the impedance is at this point. So what we would do, or what we still do, is we'll run load flow and look at the change in voltage for a small change in current. So we do a sensitivity analysis. We run, in this case, we would run 3 load flows so that we get the columns of the impedance matrix. And then we take that impedance matrix, convert it to the sequence domain, and then we have Z0 and Z1. That's still going to happen if there's loops in the system. But now with wandering laterals, we've put in another approach. So if we do find wandering laterals in the model, we're going to do a phase domain now. And so what we're doing is we're propagating the impedances, but we're sticking with the phase domain. So that's phase A, B, and C. We're moving these values out. And so that's effectively a 3x3 impedance matrix on every section that we're accumulating. So that means that the fault analysis is very, very fast now if you've got wandering laterals. And that's a good thing because I know a lot of you have them. And it's unfortunate if you've got them for switchgear and things because these really don't add a lot of value to the model, but they would previously slow down fault analysis. So now you won't see that slow down anymore. Fault analysis should run super fast. Okay, so let's get into AMI now. And I've got a model over here that is a piece of real world model. And I think I've brought this up in training class occasionally, as we've been working on it a good bit over the last few years. And we'll continue to work on it. But what we've got here now this is an AMI, the system is set up with AMI. So all the customers, we know hourly demands for each distribution transformer in the model, or customers, either way. So we've got these demands, and they need to be somewhere. The data needs to be somewhere where we can get at it. So if you've got MDMS systems that accumulate AMI data and compact it, and then store it in the cloud or on your system somewhere, that data is probably not going to be usable by us because it is very time consuming to get the data out. And from what I understand, those systems are somewhat proprietary. And what we're using here is strictly SQL. So relational database access languages. So the data can be in Oracle, or it can be SQL Server or Access, but we have to be able to retrieve that data with SQL. So if you've got data in an MDMS system, somehow you need to get it out and into a relational database. So let's take a look at one of those. And if I can find it here. There we go. So I've got some data sitting in SQL Server. And the tables here are, I've got 2 of these. So you don't need both of these. You can either have your AMI at a customer level, or you can have it at a distribution transformer level. So you need to have one of these 2, and that's all you need to have. And let's take a look at the we'll look. Let's go ahead and look at it in a different environment here. But so I'm going to bring up on the Forge ribbon here, this SQL dashboard. And let's see if we go into CMM here, and I wrote some of these queries up earlier, so you didn't have to suffer through me writing them. but I'm going to talk to that SQL Server database, and we're going to get the AMI DTran demands. So I'll run this query, and so what we've got here are the distribution transformers. We have a time point, and then we have demand values. So it's KW and KVAR. So this is what we're looking for when we run the analysis in Synergy. The time point is just going to be the format. I think is not going to matter because it's a time point field type. So if you're in Oracle or SQL Server, you'll need to make it the date time type of field or access. And then you may not have KVAR, so you'll have to calculate it, or you can leave it out. Yeah, something you probably want to account for KVAR if you don't have it, and so you probably want to multiply, do something to get values that you believe in. So that's what the DTran table looks like, and this would be aggregated demands for all the customers on that DTran, and that seems like that's not uncommon. The clients, some of the clients we've worked with, it seems like they have that. The data is set up that way so that it's already been added up and applied to the DTran, and maybe the meter system does that. But you can also go this route here. I'm querying the customer table. So now we've got a customer ID time point, but again, we've got the DTran sitting here. And so if we run the AMI analysis with customers, we're still going to be looking to associate that customer with the DTran in the model. All right, so I'm going to come back to this in a minute. So the AMI analysis, well, let's see here. See if I can find my windows. Nope. Go back to the technical reference here, and we've got a couple of spots that we can look at it. One we ran into earlier on this encyclopedia thing. There is AMI on page 5, looks like. So right here is this kind of one-pager overview of what I'm talking about. And these are the tables that you'll need to have. This is not stuff I'm showing is not a part of CMM, but the fact that these tables deal with customers and customer demand and all that, it fits into that world. And so we end up using CMM nomenclature for a lot of this. And CMM, the licensed tool, licensed module will in fact create these tables for you. But if you don't have CMM, you would need to go ahead and create these tables yourself. So you'll need to have a datasets table, and this is the set of AMI. So you might have AMI from last month, last year, that's been manipulated in various ways. So you can create multiple data sets, and the sets need to be identified here. So when Synergy goes and looks at this database, it'll see, okay, these are AMI data sets in here. Then you need to have either customers or DTrans. You don't need to have both. It's one or the other. And in each case, we need to have the DTran ID in there and a date time field based on Oracle SQL Server access. This one you don't need to have. We need to update this because of great feedback from clients and great help from our consulting team, Star and Johnny on this. We've made some big improvements that I'm going to show you here. So you don't need that table. So it's pretty straightforward. We just need the demand data and a data sets table. All right, so on the analysis tab here, what our goal is to run this 8760 AMI tool and to run load flows. So if we go into the settings, we can decide if we're going to run a specific hour or a range of hours. So let's just run it for a particular hour, and I can go down here and click. So Synergy hits the database, and I've got Yes, so this is the SQL Server one. It's going to hit that database, and these are all of the DTRAN, the timestamps for DTRAN demands. So let's go in here, and so that's June 28th at 9 p.m. So it's up there. And we need to, this apply button, whenever you pick out of here, this apply button's not getting activated, we're going to fix that. So there we go. We're going to run load flow. So now if I run this button, and I do this all the time, I'm thinking load flow, I click on load flow. This load flow button is going to run load flow on the model as it is. It's not going to be pulling AMI data. If you're interacting with AMI data, we want to run this specific hour. I have to be sure to click that right there. So there's a little bit of a flash. You may not have seen it on the web. It was going out, hitting the database, grabbing the demands, putting them in the model and running load flow. And so we get the full load flow report for that particular time. We can also run over a range here. So if we want, we can run over a time range of a day. We can run, we'll just stick with this current day that we're on. And now if I run the 8760, let's try this in, sorry. So let's go with a range of months here. Hopefully things work out better for me. Range of months, and apply that, and oh my goodness. Add a loss here, because I was running this earlier and didn't seem to have problems here. So now we're gonna have to suffer as I troubleshoot this. Let's go back to the Access version of the database here and see if it's better. Yeah, there we go. So I'm gonna have to go back and look at what's going on with that. It was basically saying the sequels failed, and so now I'm running, we just have a copy of that data set in Access, and so it's running okay there. Apologies now. So I'm running April through August, and because it's over a range, we're going to generate a chart instead of a table. And so now we can go in and look at the voltage. We've got the months here on these lines, and we can look at min-max voltage. We can look at demands, and we're more than happy to start adding chapters to this report as we get feedback on what we need to do. So that's over months, and if I do a year, it's going to do all 12 months, the same kind of format. Let's go back and do a day here and see if it works better now. Yeah, so if I just run a day, I've got min and max voltages, and but these are just going to be the particular hours of the day. And if we run a month, then that is going to be the min and max for each type of day. So we're running in April. And so we've got here the minimum voltage by day type. And it's going to be there's 4 or 5 Wednesdays in April. So it's going to be the minimum of all the Wednesdays for that particular hour. So that's how it works. Now, if it's updating the loads on the model, running load flow, collecting results, and it'll run through whatever range you're after here. What you might also want to do is just grab the loads and update the model with the load values. So in that case, you go back to the specific hour you want, and then you can just click apply loads right here. I think I need to apply there to select that hour, and I need to apply the loads. And then what Synergy is going to do is go out, grab the data, and then go into the model and update the load values. Now I'm not running secondary here. This is running a primary model. And so those load values are going to end up on the distributed load tab of the sections. And see if I can find some in here. It's got some short segments on these. There's one. So if we go to distributed load values, and so this is not one that's in the CMM data set, but if this was one of the CMM, or not the CMM, sorry, one of the AMI load values, then this would be getting updated here. So if you click on the update loads value, then these are the values that are going to get updated. If you have secondary in place, then there's quite a bit more that could potentially go on, but there'll be customers in here, and I don't know how deep we want to get into secondary, but if you have secondary modeling, the loads have to go at the customer level. And so Synergy will either create an aggregate customer where all the loads for that distribution transformer will get piled in, or it can create independent customers. So there's options there. If you already have customers, it'll attempt to find those customers. So there's a lot more going on when you have secondary modeling in place. Okay, so let's go look at the settings here on this again. You may have large customers in your model, and so if you do, we're going to be looking for the large customer AMI values in that same database, in the same tables. But it's probably not likely that those large customer IDs are consistent with your regular customers. And so they're probably going to have more like names or something else that's put in there. And so here is the options that we can use to try to find those large customers in the model. So just a variety of choices here on what the piece of data in the Synergy model is going to look like. And here's a large customer here. So for a large customer, what are we going to be looking for? We could look at the name. We could look at the section ID. There's this thing called an AMS link down here that we could use. And so, those are various options for how you're going to identify this large customer so that we can go in and update the load value. All right, what else did we have in there? Can you use sub hour? Yeah, so let me come back around to that, Damon, because there's a whole world of things that we need to work out and we can work out over time. But so let me get into that, the substation stuff. Okay, I'm so going to come to that. And so generators, Frank, we're not pulling in AMI generator data yet, but that's something that we're going to need to do. So right now the generators are going to be running based on irradiance profiles, those sorts of things, to get your time of day behavior. So yeah, we need to do that. Let's see here. Oh, I want to show you when Synergy runs, the output folder. And so this is a volatile spot output folder, but you've got an output folder somewhere. Hopefully it's not on OneDrive, by the way. Your settings, output, stuff like that should always be local. They shouldn't be on a virtual drive somewhere. That's going to cause Synergy to slow down a ton because we're interacting with this folder all the time, putting stuff in and out of here. And it could potentially cause a crash because sometimes the availability of OneDrive is intermittent. And so if all of a sudden our output folder is missing, that's not going to be a good thing. So output folder should be local, by the way. But there's a couple of these folders or files that get created. And so this CMM is going to have a a listing here of transformers and loads. Because I'm loading AMI for distribution transformers, I'm going to have a list of transformers and loads. This was a file because I just did it for 1 hour, and there's only 5 transformers on that model. But if I would have done it for a time range, this is going to be a big file, and it's going to have lots of time points in it. So this is something that you can go in and look at to make sure that the data is in here that you think should be in here. Then the other thing that we write out to help with diagnostics is this SQL file. And this is the query that we run. So you copy it and paste it into the SQL dashboard or your own SQL tool. But this is the query we're running to get the time points that we're using. So those are useful pieces of information, maybe for you, or hopefully for you there. Okay, so on the stuff that we need to do, generators, we need to get that into the model. Batteries, special types of loads. And, we could definitely use help on where's that data? Is it going to sit in the same tables? Do we need to start looking at multiple tables now? It's a lot of information, and we don't want to force you to have to bring all that together in a specific way. So if the data is in tables somewhere, then hopefully we can go out and grab it. So this is the 8760 AMI, and it does have that that button in here to apply loads. Over on the 4-driven, there's an application called AMI processing, and this has been here for a while, and it was used to, you probably recognize it a little bit, the database, the data set, and if I pick one of those, I'll get a list of demands here. This was a way that you could go out and just grab the demands and populate the model. So that functionality is now over on the analysis. What we want to do now is retool this thing and make it into a processor that will look at a data set and go in and maybe one thing would be to look at that data and create customer class curves. So if we if we can look at the AMI data, then maybe we can work through a year, and if we know what customers are like residential electric, then we could use those to create these time of day curves. So these are 576 curves, and the difference between this and the 8760 is that with the 576 curves, every Wednesday in April is the same. In fact, every Monday through Friday in April is the same. But it still has the hourly granularity, and it's something that is incorporated into many applications in Synergy, and it runs super fast. So being able to create these curves from AMI is a beneficial thing. And so as we're doing that, clients have asked us about, all right, can we start to separate out the generation? If we have net meters, are there things we can do to perhaps come up with a load value and the generation value for customers and distinguish those so that we can go in, and we're doing planning work, we can shut off the generation or try what ifs and do things to look at worst cases or trends and stuff like that. So we've got to figure out how to do that. And then car chargers is another one. We've got load here. And if customers have car chargers, it would be very useful to be able to separate that out. And the secondary model in Synergy, we have car chargers set up here so that we have a spot where we could put that sort of data. And so these aren't urgent things today, but they're things that we and you all are talking a lot about, and so we know we need to start moving on this stuff to get it in place so that down the road you can Look at car charger programs, incentive, or car chargers, incentive programs, and other sorts of things, and you've got some idea of what your car charging demand looks like on your feeder. Okay, now with okay, so yeah, so for Frank there, so the customer generators, we've got to work on that. And then yeah, so just briefly with what I thought Damon was asking about, and I see now what he's saying. Let's talk about 15-minute data in a second here. But we do have at the feeder level, when you go to a feeder meter, there is the demand profiles. And these demand profiles, if you remember from training, these demand profiles can be pulled in with interval data from the feeder. So it can be hourly, it could be 15-minute, 5-minute data. It can get pulled into this at the feeder level. So if you're doing both, if you have AMI and you have this very granular meter demand data, there's a lot of potential there to true up the two, and to do. I mean, when you pull in AMI data, ideally you wouldn't need to do allocation, right? Because this is all, if we're pulling in noon on a Wednesday in April, then we've got the demands, but there's going to be missing data. There's going to be coincidence problems, all sorts of processing that's happened through the MDMS system. There's going to be, then there's capacitors and non-meter, there's all kinds of other stuff. So if we have demands at the feeder, we run a load flow and those demands don't match the load flow values, okay, well, what can we do then to start truing those up and making things more consistent? So that's some more stuff that we're going to work on. There's some tools for that now. We need to do more. And then, so with Damon and the 15-minute data, the way that if you have your data set up at 15-minute or even 5-minute, that data is going to get pushed out into that text file. So, in the 2 minutes here, I didn't really even talk about how this works. And so I'm going to talk about the 15-minute at the same time. I talk about how this works. So when you go in and you run, let's say we're going to run 8760 with AMI data, and we're going to do it for a full year. All right. So I would hit apply here. I push the button. It doesn't take too long, but I don't want it to get in the way. Let's see here. So you see really quickly it was writing records. It went really fast. So what Synergy does is it takes this model, works down through here. Yeah, so that was a full year analysis. Grabs all of the distribution transformers in this model. It takes those distribution transformers and it puts them into this connector database. So it creates this table, this AMI connector table, and it writes these distribution transformers in there along with a lock ID if you've got lots of people using this. And so these transformers come from the model that you're using. Then we're going to take advantage of the great capabilities of Oracle SQL Server Access. And we're going to write a join that's going to grab all of the AMI values for DTrans or customers that are connected to, these transformers. And so you could have millions, you could potentially have billions of records in this database. And that query is only going to grab the records that match up with the model that you have, that you're running. So we run that query, we take the results, and then we write those out into a file. And we write the values out in sequential order. So it starts January midnight, and then we just start piling the numbers in there after that. So then we start load flow. Load flow goes, opens that file, starts at January midnight, grabs all the loads, and assigns them to the model, runs load flow, goes to the next hour. So that's why the performance is good. If you're running Oracle SQL Server, then this thing should run pretty quick for you. And certainly once the data is out of the database, then it runs fast. If you've got data setting at 15-minute or 5-minute, that data is going to be put into the text file. And what Synergy is going to do then is it's going to be working through that file. It has a specific hour. So it's going to be January 1st at 3 a.m. It's going to be going down that text file until it finds 3 a.m. values, and it's going to assign those. So the 15-minute values are going to, only one of those is going to be used. The other 3 are not. So there's an opportunity for some stuff that we can do. Perhaps we could look at averaging those, look at peaks, something, and then more work we have to do is if there's data that's missing, do we try to smooth it over? So there's a lot going on here. It's exciting that we're at this point where we can do this sort of analysis, but there's a ton more that we can that we need to get into. So gosh, I'm over time, and appreciate everyone joining us here, and looking forward to getting started with our training again. I think we're going to have some other speakers the last 2 weeks, the next 2 weeks, and then May we'll get started in the training again. And if you're at the T&D show, then please stop by our booth and say hi, and we can look at stuff in Synergy and listen to some ideas that you have. Okay, well, thank you very much, and I'm going to stop the recording and end our meeting here. We'll see you.